So we're starting today by figuring out the value of each of these sine and cosine values without using a calculator. In fact, that's going to be the theme of our day today, is being able to do a lot of these things without calculators, exact values. Now, how we do this actually goes back to how we know the coordinates of any point on the unit circle. Remember these notes that we took a few days ago. We know that on the unit circle we can find the coordinates of any point by doing cosine comma sine. That is, x, how far we go over, is always the cosine value. And so for these values that I'm trying to find here in these first 5 problems, if it's cosine, I'm just saying how far am I going over in my unit circle to get there. Or if it's asking for the sine is how far am I going up on my unit circle to get to that point. So for instance, let's see how we do this first one, sine of 0. Well, first we see where would 0 degrees be on the unit circle, and that's going straight to the right. That's always where 0 is, remember. And so if I want to know what sine of 0 is, sine, remember, we just talked about it, that's how far we go up and down. If I'm at this point over here, how far am I going up? Yeah, 0. I'm not going up at all. Therefore, the sine of 0 is 0. Okay, let's do one more together, then I'll give you a moment to do the rest on your own. A sine of 90. So 90 degrees, that's going straight up. And again, sine is how far I'm going up or down. How far am I going up in order to get to that point? Well, remember it's the unit circle, right? What is the radius of the unit circle? 1. 1 unit. That's why we call it the unit circle. And so then, how far am I going up? 1. So the sine of 90 degrees then is 1. Use that same idea to do 3, 4, and 5 here. All right, now cosine of 180. 180 degrees is going straight over to the left. Cosine is how far I'm going over. Now, in this case, I'm going over 1 in order to get to this point. However, notice I'm going left 1. And because the 0, 0 point, the origin, is there at the center of my circle, that means the actual coordinates of that point are -1 and 0. So it's a -1 for our cosine because we're going to the left. Now cosine of 270. So 270 degrees, that's going straight down. Cosine is how far I go over. So what's my cosine value here? Well, I'm going straight down. I didn't go over at all. So it's got to be 0. And finally, sine of 360. Well, we know that 0 is over here. If I start 0 and go around 360 degrees, I end up right back where I started. So sine of 360 then must be exactly the same as sine of 0. And so you notice that's how far we go up, which is not at all. So the answer there is 0. Now we're going to be building off of those ideas today as we fill in this picture. I just handed out to you this picture with all those blanks on it, and we're going to be working today to fill in every single one of those blanks. Now we've actually gotten a head start on this. We actually already have used a lot of the pieces about it. We talked about the angles, 0, 90, 180, and 270, and where they were on our circle. We also talked about a few of the sine and cosine values that were associated with it. So we're going to put those in. Now as we label this picture, you'll notice the inner ring of boxes here. You notice that in the top right-hand corner of each of those, there's that little circle. That's meant to be a degree symbol. So we're going to put all of our angles around the inside there. And on the outside, they're set up as points because we're actually going to be entering them as coordinate pairs. And so from the work we did at the start of class, we can know this. Because we dealt with the angles 0, 90, 180, and 270, so we talked about where they were. And we found some of those sine and cosine values. Remember, when we write it as a point, cosine always comes first, sine always comes second, x and y. All right, and then having found those and labeled the stuff that we already did, I now want to actually figure out what are these three angles going to be. Well, first of all, let's start with the middle one of them, right here. Notice that's exactly halfway between our 0 and our 90. So, of course, what's halfway between 0 and 90? 45, yep. So that's got to be 45 degrees there. Right, next up, we need these other two angles here. Now, as you take a look at those two angles, you'll notice that it actually divides that 0 to 90, this whole quadrant up here, into three equal pieces. So, for instance, I have a piece up here, I have a piece here, and I have a piece here in the middle. So, three equal pieces there. So, if I take 90 and cut it into three pieces, what's that give me? 30. And so the lower angle then must be 30, and the upper angle then must be 60. All right. Next up, I now want to figure out what are the coordinates of each of those points. Now, for doing that, I know it's going to be cosine comma sine. So, for instance, for this x-coordinate right here, I'm going to have to know what cosine of 30 degrees is. We know that from previous work we did. That is in your notes. It's that table of exact values that is in your notes. And so we look up that value of cosine of 30 degrees in that table. And you should be able to see in there that it gives us root 3 over 2. So the square root of 3 over 2 for the cosine of 30, therefore the x-coordinate at 30 degrees. All right, next up, I want the y-coordinate. The y-coordinate, remember, comes from sine. So then what is the sine of 30 degrees? It is 1/2, yes. By the way, as you get to know your unit circle, that should be the first value you memorize. Sine of 30 degrees equals 1/2. Partly because it's fairly easy to remember, and partly because if you're ever wondering whether your calculator is in degree mode or not, you can actually do sine of 30 and make sure it gives you 1/2 as a nice, easy way to make sure you're in degrees. All right. So then, let's go to 45. What's the cosine of 45 degrees? Yep. It is the square root of 2 over 2. What's the sine of 45 degrees? Also root 2 over 2. So notice at 45 degrees, they're exactly the same. That's because if it's 45 degrees, and if I actually drew like that triangle in there, notice it's an isosceles right triangle, because both of these angles are 45 degrees. So that's actually why sine and cosine end up being the same. All right, what about 60 degrees? Well, what's the cosine of 60? It is 1/2. What is the sine of 60? It is root 3 over 2. That combination already came up before, right? Notice, here at 60 degrees, it's 1/2 and root 3 over 2. At 30 degrees, it was root 3 over 2 and 1/2. It's the same numbers for both 30 and 60. The only difference was the order. And again, the reason why, again, if I thought about the right triangles I'm drawing in. So that right triangle there, if I know that the central angle is 30 degrees, what's this angle out here going to be? 60. And so notice it's got the 60 degree angle in it. The only difference is where the 30 and the 60 degree angles are when it comes to making those decisions. And so every time that you're dealing with those 30 degree intervals, such as 30 and 60 here, it's going to have the same coordinates involved, the root 3 over 2 and the 1/2. The only thing is just a matter of the order. Which one comes first, which one comes second. Now in terms of remembering that, you can actually visualize it a little bit. You may recall some problems that you've recently seen on WAMAP, where I asked you to put the numbers in order from smallest to biggest. That's actually going to be helpful here. Because as I take a look at this triangle down here, which one's bigger, the x or the y? Which side is longer? The x. Well, and I know that since it's a 30, it's got to involve root 3 over 2 and it's got to involve a half. So which one of those two is bigger? The root 3 over 2. The reason why you saw those questions on wall map is I was trying to kind of start training your brain to get used to seeing, well, the root 3 over 2 is bigger than the 1/2. Therefore, if I know that the x coordinate has got to be bigger, then I can know that's got to be the root 3 over 2. It's a way to remember these values. All right, now our goal today is we're going to be filling in this entire circle. So let's get back to our angle. We're next going to go to 120 degrees. And notice why I know that it's 120 degrees. Because these were going by 30s, right? And so it keeps going by that exact same amount. It keeps going by 30s all the way across. So those distances will always be 30 degrees apart from each other. So that tells me the 120. Fill that in on your unit circle if you haven't yet. Then, having gotten that, we want to find the coordinates at 120 degrees. And there's a trick to finding coordinates of the points out here. It actually comes back to an idea of something called a reference angle. And I draw the reference angle in with the horizontal. For this angle that's at 120 degrees, what is that angle that I just marked on there? Well, this is 180 here. This is 120. How far apart are 180 and 120? 60. So that angle must be 60 degrees. That's actually going to be our reference angle. And by knowing that reference angle, it's going to allow us to know what the coordinates are of that point. Before we get into that, though, I just gave you a little bit of new vocabulary. Go ahead and add this into your notes. So now I want to go back to see how we can use this idea of the reference angle to find the cosine of 120 and the sine of 120 degrees. So cosine, remember that's our x-coordinate, right? So it's going to be this value right here. Well, our reference angle, as we talked about, is 60 degrees. What's the cosine of 60 degrees again? Check your notes, check the circle if you need to. The cosine of 60 degrees was 1/2. So I know that the cosine of 120 degrees also must be either plus or minus 1/2. The only question is it going to be positive or negative? Well, looking at where the x-coordinate is, the x-coordinate is going to the left. Should it be positive or negative? That is a negative x-coordinate. Yes, so it's going to be negative 1/2. And that's how we can all of a sudden find lots of other values. Okay, so sine of 120. Well, we start with sine of 60. Because we're looking for our y-coordinate here, and we're using the reference angle of 60. The sine of 60 is root 3 over 2. Okay, should this be positive or negative? It's going up. So is going up positive or negative? Positive. And so then sine of 120 is a positive root 3 over 2. Knowing that, I can go ahead and fill in those two values on my unit circle picture. So do so. All right, and by now, I think you're going to be able to fill in a lot more of this unit circle picture. So to start with, there's still some angles that are yet to be filled in. Take a minute. Fill in each of those angle measures. So now check that you got each of those angles correctly figured out and labeled on your diagram. All right, now having completed all of our angle measures, please now find all of the coordinates around the outside. And as you do so, you're going to find lots of patterns that can make this go fast. Look for those patterns and it will make your life easier. These are then all of the values that you should have found for your x and y coordinates in our unit circle picture. Check each and make sure you filled all of them in correctly. Now that you've had a chance to check them let's talk a little bit about how we can know some of these values. First of all, like to get these points at 150 degrees, one way you could do it is you could know that the reference angle at 150 is 30 degrees, because 150 is 30 degrees away from the horizontal. That's one way you could know, but notice that it being the same as 30 means that the coordinates are the same as those, straight across from it. Which also kind of makes sense that the points that are straight across from each other should basically be the same, right?
Yeah.
Because you'll notice that for each of those points that are straight across from each other, they're at the same height. Therefore, they must have the same y values. For the x values, the only difference is that we're going to the left instead of the right. We're going over the same amount, but we're going left, which means that it becomes negative instead of positive. And so right there, you have a way that you can know that all of those that are straight across from each other should have the exact same y coordinate. And the x coordinates are just switched. You could do the same kind of reasoning when it comes to x coordinates. You notice all of them that are straight above each other, they have the exact same x coordinate. But one's going up and one's going down, so the y's are just opposites. Same number, but one is positive and one is negative. Another pattern you might observe. Notice if one of them is 1/2 and root 3 over 2, the other one is root 3 over 2 and 1/2. The order switches. You never have two of them in the same quadrant that start with 1/2, for instance. If one of them starts with 1/2, the other one's got to start with the root 3 over 2. Just check the positives and negatives along the way. And of course, all of the 45s, that is the 45-degree reference angles, all of those, you notice, are always root 2 over 2 for both x and y, just a matter of, again, watching for the positive or negative values. Tons of different patterns in here. And there's even more patterns beyond that you can find. And so, because there's so many patterns, and really so few actual values to memorize, I'm going to have you use this, and knowing that for each of these coordinates we can get our sine and cosine values, I now want you to use all of these patterns, everything we know about this, to now memorize your values out of the unit circle.